Hi, we're going to be solving equations for the next few days, and we want to start with what that actually is doing using models to represent our equation. Using models is a great way for you to actually understand what's happening when you start to solve your equations. Hopefully by the end of this unit though, however, you'll not need those models to actually solve your equations. You should be able just to do them mathematically. But it's a great way to start. It's a great way for you to really understand what you're doing and why. Alright, so let's go ahead and start. And it says here that equations involving a single variable, meaning there's just one x, and an integer can often be represented using models. The variable is represented by a single object, and in this example, the cup is what represents the x value, your variable. The counters are used to represent your integers or your constant numbers. The counters here are shown as either gray circles for positive or black circles for negative. To represent equations here using the models, we draw the same number of cups as the number of times the variable occurs, and place the appropriate numbers of counters on each side of the equation symbol to model the integers occurring in the equation. Here are some examples of these models. So let's take a look here. In example 1, all we're looking to do is to understand how this is set up. In example 1, we have the equation x plus 4 equals 5. So let's look at what our counter is. Remember that the cup represents your x. Since we have one x, we have one cup. Plus 4. 4 is considered a positive number here, so we have 4 gray tiles. On the other side of the equal sign, it equals 5. That's also positive, so we have 5 positive tiles. And we'll get into how to solve these in a minute. On the second example, the difference here is that this time we have 2x, so that's why there are 2 cups. Plus 3, those are still positive, so we've got 3 gray tiles, equals 6, and so that's why it equals 6 tiles on the right. And the last one, we have 3x, so that would be 3 tiles, minus 2. So minus 2 represents a negative 2, that's why those tiles are black, and this equals 1, and so that's why we have 1 gray tile. So now that we've kind of gone over how to set up your models, and there's a lot of different ways you can set these up. You don't have to necessarily use a cup and circles. You might, for example, use plus signs or minus signs to represent your positive and negative numbers. You might use triangles or squares or cubes to represent your x. Just know when you're starting out, whatever you start with, you want to use throughout your entire equation. All right, let's look at starting with some one-step equations using models. So here, let's go and just jump right to example 4. It says to solve x plus 2 equals 5. I'm sure most of y'all are sitting there right now and you already know what x is. What number plus 2 equals 5? These numbers are very easy. But the point of this lesson is not just to get the answer correct, but understand why it is the way it is and being able to use a model to do that. So let's look at first our model. So we have 1x, so we have 1 cup, plus 2, so 2 gray tiles for our positive, equals 5, so we have 5 gray tiles. We remove the same number of counters on each side. So since I have 2 counters here, I can actually remove 2 counters here, and that's what this step here is doing. These 2 are taken out, or they eliminate each other. And remember, the goal of this is to get 1 cup or 1 variable by itself. Well, once we have that, we do have just 1 variable here. We have 1x. Those 2 are gone, equals 3. So that's how we're going to work those. If you have the same tiles on the sides, you can eliminate those. They eliminate each other. Let's try some with some negatives in here. So we're using this equation right here at the very, very top. X minus 4 equals 2. So let's look at our picture. We have 1x, so I have 1 cup, minus 4, so that 4 is negative. That's why there are 4 black tiles, equals 2. This time, these tiles do not counteract each other. Why don't they? That's right. One of them is negative and the other one is positive. They don't cancel each other out because they're not the same. So what we're going to try to do is we're going to try to get these negative symbols gone. We want them out of there. Well, the way you get rid of a negative is by adding a positive. So since I have 4 negative tiles, I'm going to add 4 positive tiles to that. So jump down here and you can see what that looks like. My original equation was the 1 cup and the 4 black tiles. Well, now I have added these 4 tiles to counteract these 4 black tiles, and now those cancel out. The thing to remember is whatever you do to one side, you have to do to the other. So since I added 4 gray tiles, I also have to add 4 gray tiles to the other side. Now I have just one X, and this time it's going to equal 6. The great thing is you can always go and check your work. You can go back up and take your variable and plug it in for X. So here we've got 6 minus 4. Well, 6 minus 4 does equal 2. So you can always, always, always check your work. Look at doing a two-step equation. A two-step equation is when you have more than just one variable. So here I've got solve 2x equals 6. Well, I've got 2 cups, that's the 2x, equals 6 tiles, that's that 6 on the side. What I'm going to do here is I'm going to divvy up my tiles per cup because we want it to ultimately be x equals something. And I can't just get rid of my x, so I'm going to divvy up my tiles, and that's what they're showing you right here. 3 tiles goes with 1 cup, 3 tiles goes with the other cup. That means that 1 cup has 3 tiles in it, so x equals 3. And again, I'm sure some of you already knew that answer when it first started out, but now you know why. Good luck.